So quadratic functions in vertex form. Remember, the reason why it's a quadratic is because it has x to the second power in it. So that's what we're talking about. And by the end of this, the learning target will be for you to be able to use vertex form of a quadratic to determine different characteristics of its graph. So there's going to be some things we'll be able to recognize from it. Remember, it's the U shape. So quadratic functions can be written in standard form. Let's go to my highlighter. So standard form is obviously a x squared plus bx plus c. So that's when you have it in alphabetical order, but also in order by exponent. So largest exponent first, then x, then no x at all. But we can change it to a form called vertex form, and that is what this looks like. So today we'll talk about the advantages of vertex form. But let's use this. And these are called annotations, folks. And I hope that you're following along with me and you're highlighting or you're underlining or you're adding these to your notes, because that's really what a good note taker does. They do more than just kind of take what the teacher does. They listen carefully and then they write along with them. So that vertex form has a heavy emphasis on this value and this value because it's the vertex or the turning point, also known as the TP. All right, and we've been seeing that a little bit so far. Now the TP is interesting because it is an x and a y value, but we do call it the h and k value because typically these equations already use a y and an x. So the k value comes out the same. So whatever k is, that's what it is. But the h value is always the opposite. So OPP, opposite h value. And so that is going to be helpful for us when we talk about this today. All right. So a little bit of a setup. Obviously, don't have a lot of context yet, so we'll get there with a couple examples. So here we go. So let's consider the basic equation f of x, and that just being x squared. So here we have f of x already on the paper for you. So that's what's graphed right here. So it's got a turning point. It's got these points right here. Okay? So that one's been graphed, and now we want to graph this new function g of x. And g of x is in turning point form. So let's use our calculators and just enter it into the equation. All right, your calculator, type it in exactly as you see it. So if there's parentheses, use parentheses. But we know we got to go to y equals. And let me use the large screen. So parenthesis, then that variable button, which will pop up as an x. We are subtracting 2, closing the parenthesis, raising it to the second power. Once we get that far, minus 4. Okay? And again, it's like we've been doing before. We go to the table. We can't just assume by looking at the graph. We have to go to the table and kind of find some things. So we're trying to find that U shape, and we can see that the numbers are starting to increase, and they're going to go on forever and ever, and that's not a good direction. So let's maybe go up a little bit on mine, and aha, I have found it. I have found the 5 with the 5, the 0 with the 0, the -3 with the -3, and then the -4 smack dab in the middle. All right. Brennan, you with me? All right, excellent, man. Just making sure. So those are the values that we want to use, and those are the ones that we're going to want to plot. So let's go back to the note, and let's go ahead and graph those, and just maybe kind of do a double take here of what they were. -1, 5. So having trouble graphing, hopefully we'll get the hang of this, and we'll not have too many more trouble, because we always start from the origin. -1's to the left, up 1, 2, 3. 1, 2, 3, 4, 5. My eyes were deceiving me a little bit there. And then we just keep going with 0, 0. All right, so that one's easy. That one's right here. And then we had 1, -3. So 1 to the right, down 3. 1, 2, 3. And then it was the turning point at 2, -4. And then it's just going to repeat the height on the opposite side. So once it hits this turning point, it's going to be the same height on the other side. So 1 over, and then 1 up to match that, over 1, and then there's another 0 value, another x-intercept, and then 1 over, and I'm not even looking at the calculator because I know that the heights are the same, and the x value is just increasing by 1. So there you have it. We have drawn in the new function, the new g of x, all right? how would you need to shift the graph f of x to get the g of x? So what are they saying here? So they're saying if I have this graph right here, what would it take to move this, and hopefully this will work, ooh, it is, all right, to move this to here, okay? Well, let's see. If I go 1, 2 to the right, and then down 1, 2, 3, 4, it matches. It's actually the exact same. One more time for those that maybe missed it. 2 right, down 4. So let's go ahead and write that right here. It would go 2, ooh, I gotta change that. Oh boy. Okay. It would go 2 to the right, down 4. Now, that's kind of interesting because let's take a look at what the turning point was. The turning point was a -2 and a -4. So the turning point in the equation kind of helps us out with what we have here. This turning point was at +2 and -4. And remember what we said from the very beginning, that it's going to be the opposite of this number and the same as this number. So it went from a -2 in parentheses to a +2 as the point. The -4 stayed the same. So turning point, your TP is simply going to be 2, -4. And I got a phone call, so just a minute. Where do we see the turning point in the vertex equation, in the vertex form? Well, if we have g of x equaling x minus 2 squared minus 4, it's right here. It's the opposite x value, and this is the same y value. And just kind of look above at what we've done, all right? So we've got this quadratic, all right, quadratic equation that's in vertex form. So you can look at the choices here. And we want to be able to pick that out. And you're like, how in the world am I going to be able to pick out an equation just from this picture of the graph? Well, you go to the turning point. So the turning point right here, and just count it out, is 3 to the right, from 0 that is, 1, 2, 3. So that's +3 and down 1, 2, 3, 4. So the TP is 3, 4. But when I go to write this equation, okay, it's always y equals, starts with a parenthesis x. That's always going to be the case. Remember what we said about the x value, or that h value. If it's +3 for the turning point, it's in the equation as -3. Then we square it, and then, oops, this was a -4. Yes, thank you. Thank you, Caleb. That was down for -4, and so this would be -4. That number stays the same. So where do we see that equation? Well, this was a +3, +3. They forgot to switch the x value to a negative, so that's not correct. So it's either 1 or 3. They switched the y value for this one, which you do not do. That keep that the same, so it is choice number 1. Quadratics that are in vertex form, I would like you to name the turning point. Now there is a distractor here. This 5 and this -2 is just a distractor in terms of the turning point. You don't have to worry about those when you're trying to come up with these. So look at the first one. We've got x minus 8 squared plus 5. Hopefully you're thinking +8 because it's the opposite of this, but the same as this one, +5. So your TP, your turning point, would be 8, 5. We go on to the next one. The TP for this would be, again, looking at the number in the parentheses and the number outside of it, not worrying about this number. Opposite of 1 would be -1, and then the y value would stay the same for -4. I ask that you try to do the last one on your own, and then I'll put up a poll question. And so this would end with a opposite x value, +3, and then a same y value of -10. All right. So far, we've just talked about turning points. Now we're going to talk about a number in front of x squared and how that changes things. So this is on the back, and I've tried to make this as simple as possible, knowing that this was going to be done virtually. So here we go. Again, f of x has already been graphed. So this right here, this parabola is already graphed. This is the f of x equaling x squared. It's kind of what we base everything else off of. Using the calculator, we're going to graph g of x, which is half of x squared, and h of x, which is twice of x squared. And we're going to use our calculator to kind of help us out with this. So calculator, go to y equals, clear out whatever you may have, and we want to do half of x squared. Well, a few different ways you could do this. I'm just going to go x squared divided by 2. Okay, so that will do what it needs to do, which is give me the values for half of x squared. So second graph, and I want to look for that turning point, and it looks like I might need to go up a little bit. Okay, so I think I found it. So the turning point is still at 0, 0, and I don't have to graph the half, so just graph the whole numbers here. So -4, 8, -2, 2, 0, 0, 2, 2. All right, so let's go ahead and do that. So we just saw that g of x is wider than f of x, and that means that the parabola is growing slower than f of x. Now let's change that up to an equation where we would multiply it by 2. So 2 times x to the second power. And so again, we want to look at the table of values, second graph, and we got some much bigger numbers. So let's see if we can identify that turning point. Oh, there it is. It is 0 again. So the values I want to kind of make sure I graph are the -2, the 8, the -1, and the 2, 0, 0, 1, 2, 2, and 8. All right, to get that U shape again. So we notice that the difference between f of x and h of x is that h of x is taller than f of x, and that h of x will grow faster because you're doubling it. You're multiplying it by 2. So multiplying a quadratic function, something that's in x squared form, changes the width of the parabola. So it changes how wide or how narrow it may be. Now let's take one last look at something that will change the direction of the parabola, and that is when we have a negative. So negative x squared on the graph. What's this going to look like? Well, graphing calculator, help us out here. I'm actually going to put both in. I'm going to put the old x squared in, and then we're going to compare it to negative x squared. So I've put both of them in just to kind of have a baseline. I am going to graph this one. So I don't always do this with you guys because I don't want you just to kind of eyeball it. But there's x squared, and oh, look at that. The negative did exactly what we thought it would do. It turned it upside down. So now it's got that U shape going in the opposite direction. And if you want to look at the table, second graph, obviously you can see that the y values have become their opposite. +9 there, -9, +4, -4, 1, and then -1, 0, 0. So let's just go ahead and plot this one down as obviously it starts here, but it's going to have a downward flight to it. So it's going to be the same shape, the same size, didn't change the width, but it is going to be facing downward. So as you can see from our graph on the graphing calculator and what we put up on the graph itself, multiplying x squared by a negative causes the parabola to turn downward. All right, so let's put it all together here with one more multiple choice, and let's see if we can come up with the whole equation for this. All right. So we need to identify the turning point. And so that is 1 to the right of 0 and up 1, 2, 3, 4, 5. So it's at +1 and 5. So let's go ahead and write this as y equals parenthesis x and then parenthesis, and now we got to fill in some gaps here. And this would be squared because it's a quadratic. Well, if this is a +1, hopefully we realize that it's -1 in the equation. And if this is a +5, well, that stays +5. But here's the new thing. What's going to have to go here for this to turn downward? Because it's downward, it is a negative. Now, is its width changed? Well, we know that the standard x squared is 1, 1, and then 1, 3, 1, 3, so it looks like it's a normal standard width. So we need a negative, so that's a +2. This is a positive, so those are out. We need the x value in the parentheses to be the opposite, so this is out. So, oops, no, this is in. This is in. Ooh, I'm looking at the wrong thing. This is in, this is out, and so it would be choice number 4. All right.